We quickly consider example 6. Under example 6, we are given that the diagram PQ is a tangent. There's a tangent here. PQ is a tangent, it touches the circle once at P, and XP is parallel to YQ. You need to be careful here. There will be presence of or the use of theorems such as either corresponding or alternate because of the presence of parallel line. Now, we have this angle at X to be 80, and we have this angle XPY as 56. One thing about circuit geometry is that the theorems are not against one another. The fact that I use one method, you may also observe another way of solving it. So far, you didn't contravene, you didn't go contrary to the theorems. You will still get the same answer, and both solutions will be correct. So in this case, let's look at it. Since this line is parallel to this line, let's take care of that parallel first. The angle here will be equal to the angle here. That's alternate angle. For if you still need help on line and angle geometry, go back to the previous class we already had on this YouTube channel and watch how we treat, how we apply those theorems: alternate angles, corresponding angles, vertically opposite angles, then sum of angles in a polygon. So this 56 will come here. So we say this place is 56. You give reason. When you are working it in theory, you just say angle XPY equals to angle PYQ equals to 56 degrees. And you open bracket and say reason. Alternate angles are equal. So once you give reason like that, you are okay. Then this one is this. The next one we can look at is, look at this, consider triangle PXY. We already have 56 here, we have 80 here. For you to find this angle here, you just say this angle, you say XPY plus YXP plus XPY equals to 180 degrees. Sum of, you put in brackets, sum of angles in a triangle. So add these two together and subtract from 180 to get the required angle here. That is 80 plus 56 should give us 136. Subtract 136 from 180, that should give us 44. So this place is 44 degrees. Now, since what we have to find is PQY, the angle outside here, no, it's not inside the circle again. That means that angle, the theorem of circle may not apply to it because it's already entirely outside the fold. So here, we now look at this. But if you look at this one is 44, this one is 80. Look at the angle here. This angle here is between the tangent, because we are given the tangent and we have not said anything about it. And whenever you have tangent, it's either you have a radius, but the center of this circle is not indicated. There's nothing like radius or diameter. You cannot assume that this line has passed through the center if it has not been given so. So we have this angle here between the tangent and this called PY. And you know what the theorem angle in the alternate segments, what it states is that angle between a chord and a tangent is equals to the angle that that chord sustained on the alternate, on the other part of circumference, which is this one now. It is this chord PY that sustained this 80. That means that 80 equals to this. Since this one here is between tangent and that chord PY, and the same chord PY that sustained this, you can see that this 80 is facing chord PY. So this and this will be equal angle in the alternate segment. Hence, if you now consider triangle PQY, we already know this angle 56, we know this one 80. For us to find the required angle PQY, we just add, we had 80 and 56 together, 80 plus 56, we add them together and subtract from 180. Subtracting from 180, that should give us 44 degrees. So that's the answer for example 6.